Hey y'all, today is Monday, May 2nd, and we are doing some review of angle relationships, circumference of circles, and area of circles in preparation for our basic skills quiz that will be on Wednesday this week. So let's get started. This is page D31 in the packet that you got today. It's one of these riddle pages, but we're not going to worry about the riddle. We're just going to do the math in this video. So part 1, complete each statement. Now, two angles are complementary, and you need to know that vocab term, if the sum of their measures is 90 degrees. That means they add up to make 90 degrees. Okay? Now, number 2, two angles are supplementary if the sum of their measures is 180 degrees. So two angles that add up to make 180 degrees. Now, number 3. The complement of a 30-degree angle has a measure of. Well, hopefully you look at that highlighted word complement and think that it looks like complementary. Okay, so I know that I've got one angle that's 30 degrees and the two angles together are going to add up to 90 degrees because it's the complement, right? So 30 degrees plus x equals 90. Well, that means 90 minus x, or 90 minus 30, sorry. Let's actually write this down. We have x plus 30 equals 90, right? Because they're complementary. I would subtract 30 on both sides. And I would end up with x equals 60 degrees. So 60 degrees is my answer. Okay. Now, number 4 is very similar. We're talking about the supplement of a 65-degree angle. So hopefully you see that word supplement and think supplementary. These two angles must add up to be 180 degrees. So we've got one angle that's 65, one angle that we don't know. So I could say x plus 65 equals 180 degrees. How do I get that x by itself? Well, I subtract 65 on both sides. So 180 minus 65 is going to be 115. So x equals 115 degrees. Okay. Now part 2, it says find the measure of each numbered angle. So I'm going to find this angle right here for number 5. And what I notice about these two angles is they form this straight line together. And when two angles form a straight line together, I know they add up to 180 degrees. So I'm going to call this one x. So I'm going to write an equation. So x plus 128 equals 180 degrees. Now I just solved for x, so I subtract 128 on both sides. So x is by itself. 180 minus 128 is 52. So x is 52 degrees. So that's my answer for angle 5. Okay, let's look at number 6 right here. So again, I'm trying to figure out this angle measure right here, number 6, and I noticed that it lies along this straight line with that 73-degree angle. So because they lie along that straight line, they add up to 180 degrees. So I could write an equation very similar to the one I just did. Let's call angle 6 x. So we could say x plus 73 equals 180. To get that x by itself, subtract 73 on both sides. So x equals 180 minus 73, which is 107 degrees. Okay, moving on, we're going to figure out 7, 8, and 9 here. Now, the easiest one for me to figure out is angle 8. So what I want you to notice about this angle that's 80 degrees that we know, and this angle, angle 8, that we don't know, is that they are directly across from each other. So two angles that are directly across from each other are vertical angles, and vertical angles are congruent. That means they are equal. So I know that these two angles have the same angle measure. So angle 8 is going to be 80 degrees. So now I got to figure out 7 and 9. And notice those are also directly across from each other, right? So two angles that are directly across from each other are vertical angles, meaning they're congruent which means they have the exact same angle measure. So I know 7 and 9 are going to have the same answer. Now, it doesn't matter which one I look at, but let's look at 7 and notice that angle 7 and that 80-degree angle, so this 80-degree angle here and angle 7 right here, together they make that straight line, right? So I know that together they add up to 180 degrees. So could I call angle 7 x and write an equation that would look like x plus 80 equals 180? I could. Then I could solve for x. So I would subtract 80 on both sides. So my 80s cancel out, x is by itself, and 180 minus 80 is 100 degrees. So I know that angle 7 is 100 degrees, and angle 9 is also 100 degrees. Okay? So let's actually box in my answers, because I like to do that. It helps me stay a little bit more organized. Okay? Let's look at number 10, 11, and 12, because it's very similar. So 11 is the easiest one for me to figure out because it's directly across from that 65-degree angle. So I know that angle 11 is 65 degrees. Okay, I also know that 10 and 12 are going to be the same angle measure because they're directly across from each other. They're also vertical angles. Okay, now one thing I notice is that this angle that we were given, that is 65 degrees, and angle 12, when I look at them together, they make that straight line, right? So I know that those two add up to 180 degrees. So if I were to call angle 12 x, could I write an equation to solve for angle 12? I could. So it would look something like x plus 65 equals 180. I would solve for x by subtracting 65 on both sides. So 65 is gone, x is by itself, 180 minus 65 is 115. So I know that angle 12 is 115 degrees. And I also know that angle 10 is the same thing because those are vertical angles, remember? Okay, numbers 13, 14, and 15 again are very similar. What I would start with is angle 14 because it's directly across from the given angle. So those are vertical angles, so I know that they're the same. So angle 14 is 144 degrees. Now I also know that angle 13 and angle 15 are directly across from each other, so they're vertical angles. They're going to be congruent, which means they have the same angle measure. I just got to figure out what that is. So one thing I notice is that this 144 degree angle that was given to us right here, and then angle 13 right here that we don't know, together they make that straight line. So I know that together they add up to 180 degrees. So could I call angle 13 x and write an equation to solve for x? I sure could. So x plus 144 equals 180. To get that x by itself, subtract 144 on both sides. So my x is by itself, and 180 minus 144 is 36. So I know that angle 13 is 36 degrees, and that means that angle 15 is also 36 degrees. Okay. Now, angle 16 right here. So one thing I notice is that I've got three angles. This first one right here, because of that box, I know it's going to be 90 degrees. Okay. Then I have another angle that we don't know, angle 16. We don't know how many degrees it is. And then I have a third angle that is 38 degrees. And I notice that all three together make that straight line. So all three of them together will add up to 90 degrees. So what I know about just these two, angle 16 and this 38 degree angle, is that they also have to be 90 degrees. They're complementary. So could I call angle 16 x and write an equation to solve for x? I sure could. So we could say x plus 38 equals 90. Okay, so now to get that x by itself, subtract 38 on both sides. So my 38s cancel out. X is by itself. So 90 minus 38 is 52. So angle 16 is 52 degrees. Now I could have done this by saying 90 plus x plus 38 equals 180. That also would have worked. So 90 plus x plus 38 equals 180. You have like terms here and here, so I would combine those. So 90 plus 38 should be 128. And you would subtract 128 from 180 to get 52 for x. So there are a couple different ways that you could have done that one. Okay, let's look at numbers 17 and 18 in the next diagram. Okay, so what I noticed right off the bat is that 18 is probably the easiest for me to figure out because I have this angle here that I know is 90 degrees, and then this angle here that I don't know, right? But I know that together they make that straight line. So if this one over here is 90 degrees, and I know that they add up to 180 degrees, this one also has to be 90 degrees. So angle 18, I know is 90 degrees, okay? Now, angle 17 and a 67 degree angle. I could look at this a couple different ways. I could say that angle 67, this 67 degree angle, plus angle 17, plus angle 18 that I know is 90 degrees, they make that straight line right there. So they all three add up to 180. But if I know that angle 18 is 90 degrees, I know that these two together also have to be 90 degrees. So I could call angle 17 x, and I could write an equation to solve for x. So I would write x plus 67 equals 90, and I would just solve for x by subtracting 67 on both sides. So x is by itself, and 90 minus 67 is 23. So x is 23 degrees. That's what I would get for angle 17, 23 degrees. Okay, moving on to this one right here. So I've got three angles, and I know that those three angles will add up to 90 degrees. Well, how do I know that? Because this angle right here makes 90 degrees. So, and I know that all four of them add up to 180. So I know that just this side has to be 90 degrees as well. Now, I can combine these. 30 degrees plus 24 degrees is going to be 54 degrees. So I can call angle 19x, and I can write an equation. And that equation could be x plus 54 equals 90. I can subtract 54 on both sides. And I would get that x is 36 degrees. Okay. Last figure right here. So we've got to figure out 20, 21, and 22. So let's start with 22. And the reason I want to start with 22 is because this angle that's given to us is 120 degrees plus this angle number 22 make a straight line, right? We all see that straight line. So I know that they add up to 180 degrees. So if I called 22x, I could say x plus 120 equals 180. Well, to get that x by itself, I would subtract 120 on both sides, and I'd find that x equals 60 degrees. So I know that angle 22 is 60 degrees, right? Well, notice angle 22 and angle 20 are directly across from each other. They're vertical angles. They're congruent. That means they have the same angle measure, so angle 20 is also 60 degrees. So now I just need to figure out angle 21. So there's a couple different ways that I could do this, but what I notice is that it's going to be 90 degrees with angle 20. They're going to add up to 90. They're complementary. I know that because this side over here is 90 degrees. So could I call this one y and say y plus 60 equals 90? I sure could. To get that y by itself, I'm going to subtract 60 on both sides. So I get y equals 30. So I know that angle 21 is 30 degrees. Okay? So that's the end of that first little worksheet. Let's move on to our second worksheet on area and circumference of circles. So we're not going to worry about the riddle. We're just going to do the math, okay? So for number 1, we have a circle that has a line that goes all the way across it from edge to edge, and it goes through the center. Well, what do I call that? The line that goes from one edge to the other edge and through the center, I'm going to call the diameter. So I know that the diameter is 6 inches. Okay? Now, if I know my diameter, I can easily find my radius. So my radius is half of the diameter. Because remember, the radius just goes from one edge to the center of the circle. So if the whole line is 6 inches, the whole diameter all the way across is 6 inches, the radius is half of that, so I know that my radius is 3 inches. Now, C is my circumference. So there's 2 different formulas I could use. I could use 2 times pi times the radius, or I could use pi times the diameter. Okay? Now, every time I see that pi symbol, I'm going to use 3.14. Okay? And it doesn't matter which formula we use. Let's use 2 times pi times the radius. So I'm going to go plug that into my calculator. So we have 2 times 3.14 times my radius of 3, and I get 18.84. Oops. 18.84 is my answer. Okay, now for my area. I'm going to use the formula pi times the radius squared. That's the only formula I have. Okay, so I'm going to have 3.14 times 3 squared. So I'm going to go put that into my calculator. 3.14 times 3, and I hit that A2 button to square it, and I get 28.26. Okay, let's move on to number 2. So this time I have a circle, and I have a line that's given to me that goes from one edge to the center. I call that a radius, right? So how do I find the diameter that would go from one edge through the center to the other edge? Well, it would just be 2 radiuses. So to find my diameter, I'm just going to take 2.6, my radius, and multiply that times 2. So 2.6 times 2 is going to be 5.2. Yep. So I've got 5.2 as my diameter. Okay, now my circumference. It doesn't matter what formula I use. I can use 2 times pi times the radius, or I can use pi times the diameter. Both will give me the exact same answer. So let's go with 2 times pi times the radius. The radius, remember, was 2.6. Okay, so we have 2 times 3.14 times 2.6. And I get 16.328. So because I don't have really enough room to write that, let's see, 16.328. We got it in. Okay, so 16.328. Okay, let's move on to the area. We're going to use our same formula, pi times the radius squared. Okay, so to find my area, 3.14 times 2.6 squared. 3.14 times 2.6, and I hit that A2 button to square it, and I get 21.2264. So 21.2264 is my answer. Okay, let's move on to number 3. So we have a circle with a diameter of 80 feet. What would my radius be? Well, my radius would be half of that. So 80 divided by 2 is 40 feet. Now to find the circumference, it doesn't matter what formula you use, 2 times pi times the radius, or pi times the diameter. Both work. So let's do 2 times pi times the radius. So we have 2 times 3.14 times 40 as our radius, and I get 251.2. Okay, now let's find our area. Pi times the radius squared, right? So 3.14 times 40 and hit that A2 button to square it, and I get 5,024. Okay, I'm going to move on to number 5 just because it's right here. So if my diameter is 1.4 centimeters, I know that my radius is half of that. So 1.4 divided by 2 is going to be 0.7. So 0.7 centimeters. Now to find my circumference, we can use 2 times pi times the radius, or we can use pi times the diameter. It doesn't matter which one we use. I'm going to use 2 times pi times the radius. So we have 2 times 3.14 times 0.7, and I get 4.396. Okay, now to find my area, I'm going to use the formula pi times the radius squared. So put that into our calculator. 3.14 times 0.7, hit that A2 button to square it, and I get 1.5386. Okay, 2 more. Number 4. Now I have a circle that I'm told the radius is 18. What is the diameter? Well, I would just multiply that times 2. 18 times 2 is 36. So 36 inches is the diameter. Now we need to find the circumference. So it doesn't matter what formula I use. I could use 2 times pi times the radius, or I could use pi times the diameter. Both will give me the exact same answer. So I'm going to use 2 times pi times the radius. So we have 2 times 3.14 for pi times 18 for the radius, and I get 113.04. So that's my circumference. Now my area, I'm always going to use pi times the radius squared. So go back to our calculator, 3.14 for pi times 18 for the radius, but I have to square it, so hit that A2 button, and I get 1,017.36. So 1,017.36 inches squared is my area. Okay, number 6. So we're given the radius. We know the radius is 7.5 millimeters. What is the diameter? Well, to find the diameter, I'm going to take 7.5 and multiply that times 2, and I get 15. So 15 is my diameter. Now my circumference. We can use the formula 2 times pi times the radius, or we can use the formula pi times the diameter. It does not matter which one we use. So let's start with 2 times pi times the radius, and I get 47.1. I just want to prove to you that I'm going to get the same thing if I use pi times the diameter. So 3.14 times our diameter of 15, notice I get the exact same answer no matter how I put it into my calculator. So 47.1 millimeters is my circumference. And now let's figure out our area. There's only one formula for area. It's pi times the radius squared. So I'm going to go put that into my calculator. So we have 3.14 times my radius, 7.5, but I hit that A2 button to square it, and I get 176.625. So 176.625 millimeters squared is our area. So I didn't do any of the riddles, but we did all the math. This is your review for your basic skills your basic skills quiz this week. Y'all have a good day.